Okay, so let's see the final and last part of the isomers videos. So we'll just make a review of what we said until now about the isomers. The first thing is isomers of alkanes. In alkanes, there is only one way to make an isomer because there are only a single bond between the carbon atoms. So you don't have a real functional group that you can move and switch its place. So all you can do is just you can change from a non-branched alkane into a branched alkane. And how can you do that? Make the number of carbon atoms less in the main chain. So if your main chain contains 4 carbon atoms, change it into 3, and the fourth one will be a branch. If you have 5 carbons, like in the pentane, make it 4 carbon atoms, and the fifth one will be a branch, and so on. So this is called the branching, change a non-branched alkane into a branched one. And this is the only method you can make an isomer in the alkanes. What about the alkenes? The alkenes also a hydrocarbon and also contains only carbon and hydrogen atoms. But this time there is a functional group that you can move its location. So in the alkenes, you can make isomers by 2 methods. The first method is you change the place of the double bond. For example, if you have a butene, that's 1, 2, 3, 4. Take care, in this page and the previous page, I didn't draw the hydrogen atoms just to show you. But here, the double bond is here. At which carbon? Number 1. So you can shift it from carbon number 1 into carbon number 2. So that's carbon number 2, there is a double bond. So you have shifted the place of the double bond from 1 into 2. Take care, there is nothing called 3 and 4, because if you move from 3 and 4, some people will tell me, what about it's called carbon number 3? No, it's not called number 3, because you cannot call it 3. If you want to number it, you don't number like that, 1, 2, 3. Then at this time, you just number it 1, 2, 3, 4. So it will be still called but 2E. Okay, I'm urging you, if you don't understand what I'm talking about, to go back to the naming of the compounds first before coming here. So this is 2-butene. That's the first method in alkenes. So there is one method in alkenes, the branching. In alkenes, there is 2 methods. The second method is also to make a branch. So if this is an alkene, that's carbon, double bond, carbon, single, and single. The other way is to make a branch. Also, how to do that? The same way like the alkenes. So you make a smaller main chain, contain only 3 carbon atoms, and then you make a chain or a branch with the fourth one. So this way you have created an isomer for alkene. What about the halogenoalkanes? We don't have something in the syllabus called halogenoalkanes officially, but we know that this is the alkanes to which a halogen is attached, like chlorine or bromine or iodine. This is done by the substitution reaction in alkanes. This is very easy to make isomers because you can just remove the position, you can just change the position of the halogen. So for example, if this is an alkene that has a halogen at carbon number 1, you can change it and put it in at carbon number 2. You can change it and put it at carbon number 2, and so on. So we change it from here and then put it instead of 1, put it at carbon number 2, and so on. The same way applies for alcohol. Alcohol, you can do that by just changing the OH place. So this alcohol has OH at carbon number 1. So alcohols do it the same method by changing the position. So instead of being at carbon number 1, put it at carbon number 2. So that's very easy for the alcohols. Mr. I cannot do branching. You can still do branching. So you can do branching here also. If you want to make an isomer for that one, make it 2. If it is 4 carbons, for example, this branching will work with. So instead of putting it here, you can still do branching. We said we do the branching by making a smaller number of carbon atoms to which the fourth one will be attached. Take care, you will always have to make the same number of atoms. In order to be isomers, should be the same molecular formula. So here I did a branch. What is the difference between that one and that one? That one, the main branch contains 4 carbon, 1, 2, 3, 4. There is no branch coming out except the chlorine atom. What about that one? There is 3. So this is a butane. This is a butane to which a chlorine has been added at number 2. So it's 2-chloroputane. Is this the same thing? No, it's not the same thing because the main branch will contain only 3. 1, 2, 3. So the chlorine is attached to number 2, but at number 2, there is also something else. So I have to call this a propane. This is no more a butane. This is only a propane, which at number 2, a chloro has been attached. And at number 3, at number 2 also what's attached to methyl propane.
Recording.
Okay. The last part that we'll be talking about today is the most difficult part in the isomers. This usually comes only questions for the very difficult questions. It's not very difficult. You can still understand it, but you have to practice it before going to the exam. That's the isomer between the carboxylic acid and esters. So an ester and a carboxylic acid can be isomers. How does this happen? Let's see an example. I have an ester called, that's made between HCOOH. What is that? That's the formic acid, the methanoic acid, and the CH3OH. That's a methyl alcohol or the methanol. What is the ester formed? That's HC double bond O and then CH3. This is the ester that's called, it's coming from the methanol, so it is methyl methanoate. Okay, this is an ester. There is nothing new here. There is one carboxylic acid which has the same molecular formula. What do you think it will be? The ester here has 2 carbons. One it got from the methanol, and the other one it received from the methanoic acid. So it has 2 carbons. So the isomer that you are talking about also should be also 2 carbons. And because it is 2 carbons and it is an acid, it will be called the ethanoic acid. The ethanoic acid is CH3COOH. Let's see the molecular formula for both of them. The molecular formula for the first one is 2 carbons and 4 hydrogens and 2 oxygens. That's exactly the same thing like the ethanoic acid. 2 carbons, 4 hydrogens, and 2 oxygens. These two have the same molecular formula, but different structural formula. So they are what? They are isomers to each other. Again, the ester and the carboxylic acid, which have the same number of the carbon atoms and the hydrogen atoms and oxygen atoms, which means they have the same molecular formula, will be isomers. Now we can create a big list of isomers the same way. Let's try ethyl methanoate. Ethyl methanoate, how many total carbon atoms? 2 from the ethyl and 1 from the methanoate. So total 3 carbons. It will be isomer with the acid that contains 3 carbons. What is that? That's the propanoic acid. That's the propanoic acid. Well, let me give you one more example. The propyl ethanoate. The propyl ethanoate has 3 carbons from the propyl and 2 from the ethanoate. So total is 5. So it can be an isomer with a carboxylic acid that contains 5 carbons, which is the pentanoic acid. And you can try practicing in that one. And also our PDF will contain a question which came in a past paper for that part. Okay, I will call that A as the first difficult part in the isomer. Actually, the second difficult part is the aldehydes and ketones. What are aldehydes and ketones? Aldehydes and ketones actually are 2 homologous series that we don't have in our syllabus. Only in the A level. But in one of the years, there is a question about the isomers that came in the past papers for the aldehydes and ketones. You are not required to know what are the aldehydes and ketones, but if you knew the structure of them, it will be very easy for you if you face any question about them in the exam. I'm saying again, these questions are some difficult questions that come in the exam. What is in the alkanes and the aldehydes and ketones? Let's start with the ketones. Okay, we have the C double bond O. This is the C double bond O, the carbonyl group. This is the same one which is available in the carboxylic acid, but without the OH. So that's the C double bond O. Here I will put an R and R. We explained before what is an R and R. This is an aldehyde. So I can put, for example, a CH3 or C2H5, whatever an alkyl group I can put. I can put, for example, here an ethyl. Okay, so that's what I will put. That's called a ketone. What about the aldehydes? It is the same thing, but this time there is one alkyl on this side and the other side must be H. So in I was telling you that they are both isomers. So this means this part should be equivalent to that part. So if you have 1 carbon and 3 here, so here should be 3 carbons. That's C3. What comes as an alkyl group with the C3? It's a propyl. It has 7. So the total here is how many carbons? 1, 2, 3, 4. And here 8 hydrogens and 1 oxygen. Let's count here. C3 also. H is 8 and 1 oxygen. So aldehydes and ketones are both isomers to each other. Again, I'm telling you, you are not required to know that structure, but if you know it, it will be a piece of cake in the exam. You will not suffer to try to make an isomer for one of them. So that was everything almost, or all the ideas, but I just need you to know the names. Also, you are not required to know the names, but for the ketones, it is an alkanone. So a ketone that has 3 carbons is a propanone, for example. And for aldehyde, it is an alkanal. So it is a propanal if it has 3 carbons. Okay, so since that was all the ideas for the isomerism, we said that also we need to, of course, to know the definition to be able to write it and prove it. All you need to know is just to watch the other 2 videos if you didn't watch them until now, and then answer the PDF questions that will cover all the ideas. It's available in the videos number 1 and 2 and 3 for the isomers, and see you tomorrow for another revision video.